Hello, today we are going to be working with simplifying, multiplying, and dividing rational expressions. Before we can start that, we need to talk about what is a rational expression. A rational expression is the quotient of two polynomials, meaning there's variables. Our job is to break it down so we can make it as simple as possible. Remember the word quotient, that means divide. So we are dividing two polynomials. And then we're going to simplify as much as we can. For example 1, our polynomials have already been factored. So we've got factors on top and factors on bottom. So you've got x plus 1 times x minus 4 over x plus 2 times x minus 4. In order to simplify a rational expression, because it's a quotient, remember multiplying and dividing are opposite operations. So I can only cancel out things that are alike if they're being multiplied on both the top and the bottom. That's why factoring is going to be very important for us. Now, in a problem like this where it's already factored, then our first step is to state the restrictions on the denominator. The reason there are restrictions on the denominator is because you have variables in the denominator. Remember, in math, you cannot divide by 0. So, if you have a variable, then there's a chance that the denominator is 0. So, x cannot be any value that makes the denominator 0. So, for our first problem, in the denominator, I have x plus 2 and x minus 4. I have to write down what values of x could make the denominator 0. What you would do is set each factor equal to 0 and solve. So x plus 2 equals 0. If I solve that, I get negative 2. And x minus 4 equals 0. I solve that, I get positive 4. So therefore, my restrictions are x cannot be negative 2 or 4. Because if x is negative 2, it would make this factor 0. And 0 times anything is 0, which means the denominator is 0, and that's not possible in math. If you plug in 4, that makes this factor 0, and 0 times anything is 0, meaning it would also make the denominator 0. The second step is to cancel out like terms. So that means things that are multiplied with each other that are the same on the top and the bottom. In this case, that would be these two factors, x minus 4 and x minus 4. Now, all we have to do is write our final answer written out, including our restrictions. So my final answer is x plus 1 over x plus 2, where x does not equal negative 2 or 4. So you must include your restrictions in your final answer, because this is only true as long as x does not equal negative 2 or 4. Okay, looking at the you try problem, pause the video for a moment and try it yourself. So the first thing you want to do is state your restrictions. So you look at the denominator, set those factors equal to 0, and those restrictions will be positive 6 for this factor and negative 2 for that factor. Then you would cancel out your like terms, which is x minus 6, and what's left over is your final answer. So you end up with x plus 8 over x plus 2, where x does not equal 6 or negative 2. So notice you always do your restrictions first, then cancel out, because x cannot be 6 or negative 2, because in the original problem, the denominator would be 0 when x is 6 or negative 2. Now moving on to example 2, notice it says time to factor. So this problem looks more like most problems would look, because they are polynomials in standard form on the top and the bottom, in the numerator and denominator. And in order to be able to find factors that are alike, I need to factor both my numerator and denominator and find like factors. Notice, x plus 2, or x squared and x squared are in the numerator and the denominator. But I cannot cancel those out, because x squared plus 5x, and it's x squared plus 7x. Remember, adding and dividing are not opposite operations. So I cannot cancel out things that are added together by dividing. That's why we need to factor, because we need things that are multiplied together that are alike in order to cancel them. So the first thing you do is to factor the top and factor the bottom. Because they both have a 1 in the numerator, it's just a simple trinomial. So we just need what multiplies to give me 6 that adds to give me 5, and what multiplies to give me 10 that adds to give me 7. When I do that, I end up with x plus 2 times x plus 3 and x plus 2 times x plus 5. Before I start canceling out, I need to state my restrictions on the denominator again. So if I look in the denominator, the two x values that would make the denominator 0 are -2 and -5. Now I cancel out any like factors. X plus 2 and x plus 2. And when I do that, I get my final answer of x plus 3 over x plus 5, where x does not equal -2 or -5. Moving along, now it's your turn to try. So pause the video, take a moment, factor the numerator and factor the denominator, and solve this problem. Note the answer is down here in the corner so you can check your work. So pause the video now and take a moment to try that. So when you factor, you end up with x plus 4 times x plus 4 in the numerator, x plus 5 times x plus 4 in the denominator. When you do your restrictions on the denominator, you would get -5 and -4. And once you cancel out your like terms, you do get x plus 4 over x plus 5, where x does not equal -5 or -4. Now we're going to multiply rational functions. When you get a multiplication problem, the first thing you're going to do, just like when you're simplifying, is to factor everything. So that means factor every polynomial in the entire problem. Remember, when you're multiplying fractions, you simply multiply all the way across the top and all the way across the bottom. So therefore, any factors in either part of the numerator can cancel out with any factors in either part of the denominator. So, first step would be to factor everything. Take a moment to pause the video and factor all 4 of those polynomials. When you have them factored, the solutions are x plus 2 times x plus 2, x plus 5 times x plus 2 on the denominator. On the other numerator, you have x plus 5 times x plus 5 and x plus 7 times x plus 2. So the first thing you need to do once you get everything factored is to write all of your restrictions. That means any number that would make any factor in the denominator 0. So those restrictions would be -5, -2, -7, and then you would get -2 again, but you don't have to write it twice. Once you write it one time, that's enough. Now I need to cancel out all my like factors that are in the numerator and the denominator. So I have x plus 2 in this numerator and x plus 2 in the denominator. I have x plus 5 in the numerator and x plus 5 in the denominator. Because it's multiplying, I can take any numerator and any denominator, even if they're in separate fractions. I also have this x plus 2 over this x plus 2. Those are all of my like factors in the numerator and denominator. So what's left over is x plus 5 over x plus 7, where x does not equal -5, -2, or -7. So pause for a moment, pause the video, and simplify the U-try problem. So factor every single part of the fraction, find your restrictions, and cancel out like factors. Pause your video now. When I factor all parts, here are my solutions. With those as my solutions, my restrictions are +4, -3, -6, and +4 again, so we didn't need to write it twice. The things that should have canceled out are x plus 3 over x plus 3, x plus 6 over x plus 6, and that's all. Because yes, you have two x minus 4s, but they are both in the denominator, so therefore they will not cancel out. So on your numerator, you have x minus 2 and x plus 6. And in your denominator, you have x minus 4 and x minus 4. Also, be sure to include your restrictions where x does not equal 4, negative 3, or negative 6. The last thing we need to talk about is dividing rational functions. Remember, when you divide fractions, you keep the first fraction, flip the second fraction, so find the reciprocal of the second fraction, and then multiply those together. Then you would factor everything, just like before. Write out all restrictions, meaning in the original problem and after you flipped, you cannot have a 0 in your denominator. And you'll also then cancel out your like factors. So, at first, my restrictions would be negative 1 and negative 2. When I flip my fraction, so I rewrite the first one, x minus 3 over x plus 1. Now times, flip the second one, x plus 2 over x minus 3. So when I'm stating my restrictions, I use the original problem. X cannot be negative 1, it cannot be negative 2. I also look when I flip the second fraction, x also cannot be 3 because that would make this denominator 0 as well. So that's all of my restrictions. Now that it's a multiplication problem, I can cancel out like factors in the numerator and denominator. So I have an x minus 3 and an x minus 3. So my final answer would be x plus 2 over x plus 1 with the restrictions x cannot be negative 1, negative 2, or positive 3. So one more problem for you to try on your own. So pause the video for a second. Remember to factor every part. State the restrictions on the entire problem. And then cancel out like terms. So pause the video now. Okay, so when I factor all of my like terms, factor all of my problems, I get x plus 6 times x plus 8 over x plus 4 divided by x minus 2 times x plus 6 over x plus 4 times x minus 2. Then I'm going to divide. The way you divide fractions is you rewrite the first one, multiply, and flip the second. When I'm stating my restrictions, I must state the restrictions for the original problem as well as after I flip. So therefore the restrictions should be negative 4, positive 2, and negative 6. Now, when it's a multiplication problem, that's when you can start canceling out. So the things that cancel are x plus 4, x plus 6, and also x minus 2. That's how you get your final answer of only x plus 8. That's the only factor left, where x cannot be negative 4, 2, or negative 6. That is all for simplifying, multiplying, and dividing rational functions. The big thing to remember is you can only cancel out factors, which means things that are multiplied. And you must always state your restrictions because the numerator can never be 0.